We're recording. Okay, so this one, on question 4, we had another question where the answer was given. And again, there were some people who attempted to bluff it. What we've got is, now we've got to make sure that we're secure on our different types of integrals. And especially knowing when to have a natural log come into your integral and when not to, and knowing how to deal with powers here. So this is, let's start by saying this is 18 times 6x plus 1 to the minus a half. Okay, and that's essential to get that sorted first. I know that is what we started with. Now, we know that if that power had been a minus 1, this would have been a natural log type integral. But it's not, it's a minus a half. So it's the standard type where we're going to add 1 to the power and divide by the new power. So it's going to become, when we still at the 18, we're going to divide by the new power. If you add 1 to minus a half, you get a half. So we've got a half down there. We've also got the 6, that is the coefficient of x and inside that bracket. And so this is 6x plus 1 to the power of a half, between 0 and 4. And remember, oh yeah, we've got to show it's equal to 24, so we'll keep working on that for now. Okay, let's tidy this up first before we put any numbers into it. We've got 18 over a half of 6. Half of 6 would be 3. 18 over 3. Great maths. Right. So we've got that. Into which we are going to substitute the values 4 and then 0 to give us 6 lots of 24 plus 1 to the half. That feels nice and convenient, doesn't it? Take away 6 lots of 0 plus 1 to the half. You feel like things are going well when you've got 25 to the power of a half appearing. So we've got 6 times root 25. Take away 6 times 1 is 24 as required. There we go. Very nice. Then part 2 asked us to do, so part B, asked us to give the value of the integral from 0 to 1 of e to the x plus 2 squared. Okay. Now again, we haven't got, let's remember this, we haven't got an integration version of the chain rule where we can deal with a function inside a function. So we're going to have to do something else with this. We can't adapt. We can't just pretend that it's differentiation, we can deal with it that way. We have to times it out. It's the only choice we've got at this stage. So we have to multiply out this bracket. Now e to the x times e to the x would give us e to the 2x. E to the x times 2, and then another e to the x times 2 would give us 4 e to the x, and 2 times 2 is 4. Okay, so in marking all of these, where it went wrong for some people is they tried to do something really odd with adding 1 to the power and dividing by the e to the x and all sorts of stuff going on. And you've lost everything there. Some other people multiplied this out and forgot that there was a 4 at the end of it. The next thing where people might have gone wrong is, well, e to the 2x, we know that that's a half e to the 2x, isn't it? You know, if you were differentiating, you'd multiply by the 2. If you're integrating, you divide by the 2. 4e to the x is going to remain as 4e to the x. And there were some people who forgot that when we integrate a constant, we get the constant times x. It doesn't just disappear, so we've got 4x at the end, between 0 and 1. Actually, having got here, we're just about there. In fact, we've got most of the marks already. We've got 3 out of 4 marks just for getting to there. We put the limits in now, but this, we've done all the hard part. A half e squared plus 4e plus 4 take away, and if you put 0 into as the power of e, then you've got 1, haven't you? So we've got a half plus 4, and then we'd have a 0 at the end. And that's just about sorted. We've got half e squared plus 4e, and then the plus 4, we've also taken away a plus 4 there, so it must just be a minus a half at the end of it. There is our answer, and the question did say in an exact form, giving you an answer in terms of e, so a decimal equivalent was no good. Okay, and that's maths.